What's this?
Units?
Like on one half,
It's the
not
one
like
that I
across
would know.
equal signs.
We don't just use
Honestly,
tricks.
I don't use it, but our science does, and it blows their mind when I'm trying to teach an equation with proportionality, and I'm trying to set up an equation where it's, cross, whatever,
And that's why that is such a great question.
and a
Because
conflict.
every kid in the classroom is going to say, okay, I don't know when to use it, so I'm just gonna use it all the time.
All the time.
You know, I think I was in Brenda's classroom and watching the kids, they were dividing fractions, multiplying and dividing fractions. And so when you divide fractions, you take the reciprocal and multiply. Don't ask me why, just do it, right? That's what you were taught.
Cross multiply.
Just do it, do not cross multiply. You take the reciprocal and multiply.
Straight
Well,
across.
in her, top times top, bottom times bottom. In her class, when the kids were multiplying, they were also taking the reciprocal and multiplying top times top, bottom times bottom. They had no clue when to use the reciprocal and when not to. So that's what a trick is going to do if you teach a trick. They're not going to know when to use it, when not to use it. They're going to use it inappropriately, or they're not going to understand at all why they're doing it. And the why is what's important. I mean, the number manipulation is not the important piece to this. The why is the important piece. They could use calculators to do this, the number manipulation. It's the why are you doing this that's important. Denise.
So, I'm a teacher and I'm supposed to be teaching it. I'm a teacher and I'm supposed to be teaching this. How do I know when to question the book and when to say, well, that looks dumb, that's gonna confuse them, I'm gonna do it this other way, but my curriculum director says I have to do it this way and whatever. What do I do?
You gotta get you.
Rochelle, what do you think?
I don't think there's a problem with the book showing to do that as long as they understand why. How it works. Why does the book tell me to, flip and multiply by the reciprocal? Well, like we just had that discussion, somebody answered the why is because it cancels out that unit top and bottom. Or when you divide by the same number, you get 1. If they understand that, then
If
I
they
don't
can
think there's
explain
a
it to you,
explain.
not you explaining it to them.
Right.
If they can explain it to you, I'm good with anything they want to use, if it's mathematically sound. But if they can't explain it to you, if they say, that's what my teacher told me to do, that's what page 52 in the book told me to do, that doesn't work for me. They have to understand why.
And I noticed that yesterday or day before, that's one of the things we have to be careful with parents. My husband, I love him dearly, but he will question as a parent, of our child, he will question the reasoning behind everything that I'm teaching, which is good. It's a good conversation. So I think a lot of pushback, huge pushback we're getting from parents is we're teaching it differently the way they learned it, but I think we're sometimes teachers and administrators, we're all adults, so really piss parents off. Is you're saying you're doing it wrong. You need to stop helping your child. It's like, really? You're gonna tell me not to be involved in my child's education?
Exactly, it's my child.
And then it becomes, what was wrong with the way we did it? It seemed to work fine then. We need to kind of,
Open the floodgates.
that's where a lot of it's tapping all over the nation.
It is.
So we
And a
need
lot
to
of that
kind of
is
change the way we approach it.
I think, Crystal had your hand up, or was it Jen?
It was me too, but
Okay.
that's, we don't talk politics in our house, but we are in Texas and math did come up. And I did not understand the way that they're teaching it conceptually until my younger son actually taught it to me because he's actually gifted in math. So he's like, no, Mom, it's this way. And I wasn't in school yet. And I'm like, wow, he really understood it. So I was able to get it from that perspective. But I think a lot of parents don't have that very bright child. And so like, I was like, wow, my son can really understand math. I mean, he was explaining, like one day we were in the car and he's like, you know why you can inverse fractions and multiply them when you're dividing? And I'm like, no, like, I don't know. And he explained it to me and he explained it, he was 8. And he just, it made sense to him. And so I, of course, started studying it a lot harder, because I'm like, this is neat. But I don't think everybody has those bright children. A lot of times our kids fall between 85 and 105. And those kids struggle with the concept longer. So what I did for that was I put them on Khan's Academy. Because Khan's Academy will kind of teach the concept too.
Very procedurally though.
But it
When
does,
they're
but for the parents, it was all
For
the
the
bridge.
parents, that's-
Yeah, oh, it wasn't the kids that I put on there, it was the parents. And I said, anytime you have a question, a lot of times Khan Academy will explain it in a way that their brains can like bridge the gap. And so that was my way of kind of connecting with the parents instead of just saying, stop messing up my instruction, you're giving them cheats and I need them to understand it.
Yeah.
So, and then also sending home some of the STAR questions where they have to say, these manipulatives, how would you represent this? And the parents don't know it,
Yeah.
then they're like, well, how would you? And then that opens it up. But yeah, you're right, you have to be careful not to say,
And who is your son's teacher?
my son's teacher.
Mm-hmm.
Who was he that did it?
Yeah,
Her name was Miss Sparks.
I want to go thank that teacher. I got chills when you said that. 'Cause
She
that's
was-
a phenomenal teacher.
She was, and you know what, it's so funny, when I was doing my student teaching, I walked in on her one day and she's like, I'm like, what are you doing? She's like, I'm lesson planning. And I'm like, Miss Sparks, how can you do that? I was like, how can you? But she spent tons of time lesson planning. And so her instruction was dead on.
So how many in here can explain why you take the reciprocal and multiply when you're dividing fractions?
I need some pattern blocks.
You can do it with pattern blocks
I need some rods.
or Cuisinart rods, but y'all weren't taught, were you?
No.
I wasn't taught, y'all weren't taught, I bet Dr. West wasn't taught, Denise wasn't taught. She wasn't taught, I can tell by the blank look on her face. Yes, ma'am.
Well, when you're dividing, the whole object is to get a single or a fraction, right?
A unit?
Sometimes, so my theory on it when I was in college, before my professor passed away from Katrina, or Hurricane Ike, Hurricane Ike in Houston, he was explaining this, and it was about the power of you want to get one. So in order to get one, you have to take the reciprocal, and when you cross multiply the two fractions of the reciprocal, or not cross multiply, multiply straight across, because I get upset at her when she says that. It ends up canceling out and making one. But then you still have that bottom fraction, but it can only get rid of one side, or one of the pieces that you put up. I mean, it's easier to show visually, but that was a concept that he was going through until we got a student teacher that knew nothing.
Okay. So I'm gonna write this back up here, the way it should be written mathematically.
Is it appropriate / proper / whatever word you want to use, to say cancel
That's a debate that's going on in the mathematics.
or reduces to 1? Is that like more appropriate?
Simplify, you can't say
Simplify.
reduce,
I'm
but
sorry.
simplify.
To one.
And canceling is really not appropriate. You would, and Pam said it, or Kim said it, one of them said it, that this is, when the numerator and denominator are the same, that's equivalent to 1.
Equivalent to 1.
Equivalent to 1. So I'm gonna write this back up here the way Pam had told me to write it, which was, remember Pam, what you told me?
Hold on.
I remember what it was. It was 9,600. We changed the liters to
Milliliters.
milliliters.
960.
So it was 960.
Oh, we've already multiplied.
Yeah, 0 and
960. What did
It's
you say it
X
was, Sam?
and G for grams.
Milliliters.
Yeah, what number? What did you,
number?
how did you read
960.
that? 960. Was there an and in there?
No.
There is no and. Where's the only time you say an and?
Decimal.
There's a decimal. Okay, because I heard some of you say and.
Yeah.
Okay, and that's over,
Centimeters, 1 centimeter.
or
Centimeters. I'm
centimeters.
sorry, 1 milliliter.
Okay, because we converted this to milliliters. And then we're multiplying that by, okay, we already multiplied
We
it.
already multiplied it.
All right, I've lost myself here. Where are we? Where am I?
You need the grams, the 19.
Yeah, I do.
3/10
That's what I need.
Great.
Times 19 3/10 grams
Right.
Over 1.
Centimeter.
per 1, and we've converted it to milliliters.
Equals
And that equals
X grams.
X grams. Okay. This is over 1, understood. So we multiplied, and what did we get, that big number?
18,000.
18,000.
528
528, and we determined that that was
grams
grams. Because the milliliters actually
become one.
become one. You almost want to say cancel when you're talking
I know.
about units. And I'm not that particular, I would let you say cancel, but don't say cancel when you're talking about numbers.
The units.
So now, this is the, what is this?
Mass of the golden.
That's the mass of the gold, of the
Statue.
Yeah.
Idol golden statue.
So we're done.
No.
No.
Oh, that's not the question.
That's not, what is the question?
What should the sand be
What's the volume of that?
How much sand do we, what's the volume of the sand that we need?
that we need?
That we need. So now what do we do? Let's see, good, I'm not asked yet. Okay, Amanda, what do we do now?
To be really honest with you, I have no idea.
Okay, Brenda, you can phone a friend named Brenda.
And Brenda knows.
Now we're going, wait, am I supposed to be asking questions?
Now, you're telling you what we do next. She phoned you.
Now you're going to set up another equation of the density equals mass divided by volume,
Okay?
In
I
this
love
case,
the way you
this
said
is-
mass divided by volume rather than mass over volume.
So we know the density of the sand, so we're going to substitute in 1,1201 kilograms per, I'm sorry, over, divided by milliliters cubed.
What was the
The
density?
density is
1,201,
201.
201,
Yes, ma'am.
201, okay? Grams.
Yes.
No, kilograms.
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 Or kilograms, grams.
Per meters cubed.
You tell me you're using this formula.
Yes, some
We can
So
still have
I'm not
a
done. It's kilograms per meters cubed,
density.
or divided by 1 meter cubed.
Okay, cubic meter. That right? That was it, right? I'm not looking up there on purpose. I want you to tell me.
Equals, we're going to also substitute in for the mass, the same mass that we just found for the gold.
18,528 grams.
Is that wrong? We just messed up something?
18,528 grams
Over X.
over,
That's an unknown volume.
okay, and what unit is this going to be in?
It should be in.
Volume?
Liters and not kilograms, so we're going to have to change. Some we have to change, or
Liters?
not change.
I'm gonna put an L here just so we'll
Yes.
remember it's, okay. a
And then
liter.
also, if you look up at the numerator,
Yes,
one's
ma'am.
kilograms and the other one's grams, so we're going to have to
Gotta
convert
change
one of them.
that to grams.
I changed them both, we're going to set them both to kilograms.
Okay, so this one's gonna remain the same.
Yes, ma'am.
Can we just put it to grams?
And still 1 meter cubed?
Yes, ma'am. In order to change for every gram, it's 100 kilograms. So we're going to end up taking the 18,528 divided by 100, and we'll end up with
You guys are trying.
18 and 528 grams. Did I just mess this up?
You divide it.
Thousandths, sorry. So 18 and 528 thousandths kilograms. Did I just mess that up?
No, we're gonna talk.
Oh.
Okay, so the number she gave me is correct, isn't it? So what did she actually divide by?
1,000.
What was she saying?
Sorry, I said 100.
Saying 100, but in her head, she was thinking 1,000. I'm assuming.
So you have to keep an eye, I've even told my kids, I'm like, I get ahead of myself.
So
So I'm like, keep an eye on me.
That's why you have to make your class
Grams.
the keeper of the correctness.
And so that's still divided by an unknown liter amount.
And now Brandon has a question.
Oh, I'm
Leader.
sorry. They,
Leader not grams.
Thank you.
I didn't think to do it that way. I converted that 1,201 kilograms to the grams.
Yep.
Yes.
You must have done it all wrong. Right? Is that wrong or right? Instead of converting the grams to kilograms, could he have converted the kilograms to grams?
Yes.
As long as the units are the same, your choice. Okay? Cody.
And I agree, that's where I did it. But I also changed the meters cube. I put 1 times 100, no, 1 times a meter times, 1 times a meter times, 1 times a meter.
You expanded it.
I expanded. Then I changed to centimeters, so it's 1 times 100 times a centimeter times 1 times 100. And I converted it to centimeters because I'm used to density equal the mass being grams per centimeters cubed. So at that point, we're above the equation right below density equals mass divided by volume. That right there, that's where I did my conversion.
Okay?
I know it's more math intensive.
That's
By
okay. I like math intensive.
That's, expanding it out into that next equation that you have below there. But at some point in time, don't you have to convert it to the standard, I say standard, but the units that we're more accustomed to?
Gee, I don't know. So what he said was, he's used to density being in grams per centimeters cubed. And now he's saying that that's standard.
Well, I'm not saying standard, but that's what I'm used
What
to.
he's used to, so if you're used to it, it's been seen a lot, right? Is that what y'all do in science? Is it always grams per centimeters cubed? Mhm. I mean, I'm math, so, I really don't know. Not always?
What's the density of
That's what
water?
I'm saying, this is asking.
I know the number, I don't know the units. Yes, ma'am?
I don't know the answer, but with the question, just says how much volume. It doesn't specify
Right.
grams per centimeter cube, so I wouldn't have gone the extra.
Okay, it doesn't
Five
specify the unit at all.
Right, so I would have, kilogram over meters cubed worked, so that's
So we're
volume,
gonna
right?
leave it like this for now, Toby?
That's fine.
okay?
Yeah,
And then
got my
Brenda's
little-
gonna continue?
In the end, you want to solve for the unknown, which is x, with not 1 divided by x. So I'm going to multiply each side by x liters,
Okay.
so that way I can get it equivalent to 1 on the right-hand
I
side.
have this written down so I can erase this. I'm out of room here. Okay, just keep in mind that that was there. So you're multiplying this side by
X over 1
X
liters.
grams.
Liters.
You changed it to liters?
It was liters.
Oh, it is liters, I can't read. Okay, sorry. X liters over 1.
And the same on the right side.
Same
What you
on the
do
right
one side,
side.
you do the other.
X liters
To keep the balance.
over 1. Okay, did y'all just hear what she said? What you do to one side, you do to the other. One side of what?
The equation
Okay, and why?
to keep them balanced.
Okay, your hand was up?
Yes, I'm going back a little bit. Can you show me why you substituted in for meters squared liters?
Who did that?
What's that? Meters squared?
Why did you?
Meters cubed, yes, cubic meters and up above. Yes, we were given the density of the sand in kilograms per cubic meter, but then we wrote X in the volume over there on the right in liters. Why did we put liters?
Why liters?
I don't know.
Cubic meter equals a liter.
Okay, Craig, what?
So the cubic meter equals a liter. Just like a
Okay.
cubic.
You said 1 cubic meter equals 1 liter.
Why
Right.
change liters?
Oh,
No? You changing your mind?
maybe
Okay.
because it says 1 milliliter equals a centimeter cubed, so it's
Like in the King Henry thing.
I can't even remember it.
So what are we gonna do?
That's until dawn.
We gotta work on our attendance. Was that another person had their hand up, say a question? Okay, so what are we gonna do? Yes, ma'am?
When you are specifying your unknown volume, since you don't know the units of the unknown volume, you can, I don't want to assume.
We chose L.
Yeah,
There.
you would choose meters cubed because you want your units to match from the left-hand side of the equation to the right-hand side.
How did you get meters cubed?
Or cubic meters?
Yeah, cubic meters. How did you get that?
It came from the left-hand side of the equation, it came from the density. That was
I guess I'm asking, how can we change a liter into cubic meters, because that's what you want me to do? How do you have to know how many there are?
I'm totally
No, because we don't know the amount. So right here, you don't know the amount here. You don't know your units here. They never specified that. So instead of saying liters here, you would say this is cubic meters. Because you went, so kilograms over,
But then,
you want your same units on both sides.
So is it like a cubic?
Because they never specified what the volume is. It just says
Cubic
how
meter
much
equals
volume.
like
Why do we have
decameters.
to?
true too. I'm gonna tell you since I knew.
But why do you have to specify? Actually,
Can we just leave the unit off?
yes.
Can we just leave the unit off? Because what you were doing right there was what Toby was doing earlier, right? All that you were-
Once you get the volume.
Can we just leave the unit off until we figure out what it is?
Yes.
Would y'all like to do that?
Yes.
Okay, so we have some units there. Okay, and also here, some units. And some unit, I don't know what. Okay, now,
So on the right-hand
hang
side,
on, yeah, Brenda has the floor.
on the right-hand side of your equation, x divided by x is 1.
Okay.
So you don't have to say 18 and 528,000 to multiply times 1 equals 18,000. So you put a line through it.
So this is,
So your right-hand side is 18 and 528,000 kilograms.
okay, and the left side?
So on the left side, you now have 1,201. Well, you can actually read it like that.
Yeah.
And now you need to move the 1,201 kilograms divided by 1 meter cubed, or 1 cubic meter. So you're going to end up taking the reciprocal. So you're now going to multiply your left-hand side by 1 cubic meter divided by 1,201 kilograms.
I thought we took the reciprocal when we did this.
We did. We're going to do the reciprocal now on the other side, so that way we can get the left-hand side equivalent to 1x. Left-hand side multiplies 1x times
This.
1, yes, and I don't want 1x times anything. So you're now going to multiply the left-hand side by 1 cubic meter divided by 1,200.
And the reciprocal of this.
Yes, ma'am.
Question, so that we isolate the x.
Yes, ma'am.
Yes, ma'am.
Aren't we doing that twice?
Yes, ma'am.
Why? Why couldn't we have
Because
left
you-
the x on the right side and just,
You would have 1 divided by x.
but then at the end you just, I don't know, I think it's,
Well, you would still end up doing the same thing.
I think it's like going back and forth like 2 times
You will
instead
do the
of.
same thing.
Hey, hang on, let me clarify, because y'all were not watching Rochelle. And she said, or Brenda said, this would end up with 1 over x if we do what, Rochelle had suggested. And then she said, and then we could just, what is she doing?
Taking the inverse
Of
the fractions.
Which is what we've already done.
what?
1 divided by.
Is that all?
She was
So
already
you
doing that
flip
one
the
side.
other side.
Whatever
She
you
was
do one
using
side.
both hands. So let me ask you a question. I'm sorry I'm taking so long to do it. So if we have 2 over 3 equals 4 over 6, is that true? Yes. Yes. And I take the reciprocal of both sides, 3 over 2 equals 6 over 4, is that still true?
Yes.
Yes. So if you have two quantities that are equal and you reciprocate both, it's still equal. Okay, do you know how long it takes some kids to realize that?
A long time.
That's a long time to realize
I'm
that.
saying
So
should-
you're going to have to show that over and over again. But since Brenda didn't start that way,
Okay.
we're going to continue with
Would you have
Brenda.
been okay with me just saying doing the reciprocal both sides? I assumed you wanted to see every step.
I do. I want to see every step,
Okay.
which is why I'm continuing with you.
Okay, sorry.
So,
So
now,
left-hand side you're multiplying by 1 cubic meter divided by 1,201 kilograms.
so that means, same thing over here?
Yes, ma'am.
So, 1 cubic meter over 1,201. Kilograms. Okay?
So when you multiply 1 times 1,201 kilograms, and you take 1,201 kilograms in the denominator multiplied by 1, you end up with 1. So now on the
this and
left-hand
this is
side,
equal to 1,
yes ma'am,
and this is equal to 1.
Yes, ma'am.
So now we have
1x, or just x.
x.
And so now you're multiplying the left-hand side, so you take 18 and 528,000 times 1 kilogram, times 1 cubic meters, you now have 18,528 kilograms.
I didn't see what you were saying.
Kilograms.
It doesn't specify.
The kilograms, your units are actually going to cancel. Can I go ahead and do that now? May I do that now? Okay, so you said with units you could say cancel, but not with numbers. So my kilograms are canceled, so instead of having kilograms, you actually just have meters cubed, or cubic meter up top. So you have 18 and 528,000 meters cubed in the numerator.
I don't see a meters cubed over here.
Over here to the left, you
Oh,
multiply.
okay, thank you.
To the right.
To the right, I said left, yeah, I'm pointing to the right. So you get that teacher backwards.
And that's divide over.
Divided
Divided by.
Okay.
And so you have 1 times 1,201 kilograms, so at the bottom you have 1,000 numerator. That's divided by 1,201 kilograms. Here, yes ma'am.
Now we're done.
And that's your cube circle.
Can I ask you? Yes.
Oh, my kilograms canceled, I'm so sorry. The kilograms are gone. Yes, I already canceled them.
Now we're done.
So then what we found was the volume of the sand needed, which is 18 and 528,000 meters cubed. Cubic meters. Divided by.
So what is their answer?
What did I get when I divided that out?
I didn't finish dividing that out, that's why it's called.
Okay, you have your phones, or your iPads, or something. Or a pen and paper.
That's 1,000.
Pencil and paper.
So that answer is divided by 1,201.
Yes.
1,201.
1.
So to what spot, what do you want?
I thought they
It's
was
like 154, 10,000.
to my only right hand side.
It's 8.
8,000.
100. Yeah, okay. 154, 10,000.
154, 10,000.
You need another placeholder.
154, 10,000. Okay,
Now
good.
let's say
And
what
the
do we have
unit
to do
is?
to match
Meters
this?
cubed.
Hey, I've got
Now are we done?
9.01.
Holy crap, this is how much sound we have.
That was so much fun. You know how to jump in the
I
right answer?
got the right answer.
I got the right number. You got the right number?
9.01. But it's complete, it's around.
Did y'all hear what Brandon just said?
Yes.
Let me tell you what he just said.
I'm
Listen.
sorry.
Brandon just said, I did it wrong and I got the right answer. So as a teacher, what do I need to do?
go evaluate.
I need
Ask
to look
him.
at his work and see if he indeed did it wrong, or indeed did it wrong, or if he just did it with a different process. Now, if he did it wrong and got the right answer, that's a problem. We need to fix that problem. If he just used a different process, and there are many ways to do this. Rochelle with her, if you just used a different process that was mathematically correct, then he's fine. Sir.
The answer you got just now, that's the volume he needed,
Of the same.
right?
Of the sand.
Okay.
No, it's the volume of the sand.
That
Now,
he needed.
now let's, well, you need to be specific, because I hear that two different ways. Ashley said it's the volume of sand. That does not ring to me the same as the volume of sand he needed. To me, that's two different. So is it the volume
So
of
how is
sand?
it stated?
How
Up there it says,
He
yeah, this
needed
is
to
what
use.
How much did he
Needed to
need?
use.
So the answer.
So the answer, so Ash needs to say that is the volume
He
he
needed.
needed.
And that brings up a great point. You want your kids to answer, they do all this work, they're lost because, multi-steps here. So they need to answer in a complete sentence so that you realize they know what they finally ended up with. So this is the volume of the sand that he needed. Any other questions? This is so much fun.
So that is the volume you're saying it's still smaller?
At first I thought it was.
Okay, so I'm thinking about this problem.
Hang on, Candace has the floor.
When I'm thinking about this problem, I set it up, differently.
We can't hear the back.
Version first.
You're gonna talk loud.
Oh, I'm sorry.
Dr.
I
West.
did my conversions first, but I'm also thinking about how would students know? I mean, I see where they need to get the volume, but how would students reason out that the mass of the sand would need to be the same as the mass of the head? Does that make sense, what I'm asking?
Oh, yeah, because
The mass-
Because you originally, when you watched the video clip, they're talking about replacing the weight, right, on that pressure sensor. So I feel like completing this problem took a lot of preliminary reasoning to be able to arrive at that answer.
Because we found volume. And in the video, it appeared to really.
You would have to reason out that for me, that mass is connected to weight, and they're replacing the weight, so then the mass you're looking for would need to be, the mass of the sand needs to be equivalent to the mass of that statue.
Yes, ma'am.
Well, I've seen this movie hundreds of times, I grew up with it. So when I first saw the question, I didn't even have to watch the clip because I have it memorized, it's burned in my brain. My first thought was, well, why do we need to find the volume? That's just stupid. A lot of kids have that. I'm that kid. I don't want to do it because I just see no logic in it. So the way I thought about it is like, why would he need to find the volume? And then I imagined in my head, Amanda and I were talking this morning, well, actually, there's water underneath. And so the volume has to be a certain way so that the displacement and so forth and so on. There's then an extension, ELA or whatever, is you create a backstory. Well, why would he need to find the volume? What's underneath?
Is that why?
And that's only if the weight had to be equal.
Yeah.
Yeah, you have the weight.
So I'm gonna leave the rest of this discussion to Miss Laura, okay? And Denise?
I'm in the boat with Amanda, just so, and I know that I don't know, because I've not had any of the background information or any of that kind of stuff. First of all, the collegiality for her to be able to say, I have to be honest, I have no idea, and then we move on. As a teacher now, what do you do with the Amandas that are in your room?
Great question. What do we do with Amanda?
I felt like a first grader looking at this in a fifth grade classroom. I'm lost. I don't do this. And
So, as a teacher, what do we do with Amanda and Vera?
Or someone who does have a better idea, so they could maybe have like quiet conversations so that she would have someone to clarify with.
So a peer tutor?
Well, yeah, but not like to where like I would separate them. I'd be like, well, why don't you go sit next to, you know, Bashari and, you know, kind of follow along with whatever she has written down.
And if they follow along, does that guarantee that they understand?
No, but it'll keep them engaged.
Okay?
It doesn't necessarily mean that they will
But I
have,
want them to understand.
well, that might take a little bit more time
So that's the
because,
question, what do we do to get to the understanding, Melissa?
What I do in my class is, they can phone a friend, they got their phone, and then they phone the friend, and they tell them the answer, and then they have to repeat it to me in different words. They can't just verbatim what that person said. So that shows at least a basic understanding. If they can manipulate the words and re-say it, then at least that's them saying it.
Did they tell you the answer or tell you the process to get the answer?
The process to get to the answer.
Okay.
So the answer, but the process of how they got to that.
Okay, and there was another hand up? Tanya?
Well, I was just gonna say,
And I didn't look at you.
and I raised my hand.
I was gonna say, you know, I was following along and I was getting like every number that everybody shouted out, I knew the number, but I was so lost with all of the grams and kilograms and liters and
Conversions.
all of those just threw me for a loop. So with those people like the Amandas and the Tanyas, you really have to sit with them and see what is it that's hanging this kid up on this process, and then work with them, you know? Sitting them with another kid may do more damage than.
Yeah, because they don't explain it conceptually. Some of them can, but many of them cannot. So really, y'all are in the same boat with Brandon. When he said, I did it wrong, got the right answer, I don't really know if he did it wrong, do I? Until I sit with him and converse. Rochelle?
I happened to go to a session in camp, trying to make a long story short. And this problem kind of fits right into areas. Do you agree that we should, if we have an Amanda and a Tanya and conversions, that we should not even be proposing this type of question until the students can maybe convert or a very simple problem? If they can't even do that, why are we giving them that?
I'm pretty sure that the teachers that do problems like this have already done simpler problems in the past, have done some unit conversions, some dimensional analysis in the past. Pretty sure the science teachers have. I'm not so sure about the math.
But if there are
The units.
But if there are still students, you know, again, maybe our 2 or 3 or 4, maybe more, but who do not get it, that is just gonna confuse them maybe even 10 times
That's
as
true,
much.
but you don't just jump into a problem like this.
No, I understand, but if they still can't do the simple problems, how could we expect them to do that?
Exactly,
This
you gotta back up.
problem would be where you can work with a small group, and then you would have this as independent. This would be that, the extension, enrichment, but the differentiation, that's it. This would be your high differentiation, while you work with the lower.
Right.
I was gonna say, if there's like 1 or 2 that are behind, I wouldn't say not do the whole problem with the whole rest of the class, maybe differentiate just their work and have them do something more simple.
Possibly.
That or just allow that student to just set up the equations and do the math that they can do and say, okay, that's good. You don't have to expect them to go all the way to the end.
Well,
Let them go to the, eventually, but initially, let's go where you can go.
Take it a step at a time.
Yeah,
Yeah.
and that's kind of like
Step at a
chunking,
time.
yeah.
Yeah. Denise?
I was just gonna say, as a principal, I want a teacher that gets that with kids. And that if they need to do a small group afterwards, I don't want them waiting for, you know, me and Elvira and Tanya and Amanda to catch up. Because it could be a year before I kind of get the whole picture. It's not because I'm stupid, it's just because I haven't had the experiences.
And time is
I
ticking.
don't want to mess that up for everybody here. But I want a teacher that knows that that's what I need and figures out how to manage that within this whole context. And I also want the Brendas and the Ashleys and the Pamelas to be able to continue to have the conversation because they're ready for it. They need that challenge. And And I want a teacher that plans with them in mind first, and then scaffolds for everybody else, because, what is the saying about something that the high tide raises all boats or
Yeah.
something? That, I mean, if you wait for the ones that don't get it, no one ever gets it.
Yeah.
You have to go here, because, trust me, I'll run as fast as I can to catch up. I will. Tanya.
Let's go to Lori.
I think that something I would have done whenever we introduced this problem, you show the clip again. I mean, it's not a long clip. If it's a homework assignment, you show the clip again. Then you have a discussion about why you're trying to solve the problem. What are we looking for, and how do we get there?
Up front.
Up front, before you ever start about with numbers and formulas and things, so that you're talking about, this gold weighs this much, and so do we, we want the sand to weigh that much too, so how do you determine how much sand?
See, I would have, as a student, and for about 2 minutes, I was looking at that and I'm like, that's not weight.
It's not the way.
So that isn't right, because they're asking, wait, no, how?
Yeah, because of the.
Well, yeah,
the
so,
clip.
yeah, if I were a student, I would have been like, okay, I'm thinking length instead of weight when I look at that answer. Right, so shouldn't that be?
Sandra's standing, so I'm sure she has something to say.
That's our signal. When you finish this, I want the last word.
Okay, I haven't finished. Anybody else?
Can I just say, one thing that I do with my students that are the Tanyas, when they're working, I have them always have a highlighter out. And when we're working a problem and they're working in pairs, and if it's something that their group has said, okay, this is the answer, if that kid doesn't understand it, they write it in a highlighter. That way, whenever I go back to them, they say they don't understand, I can see exactly where they started to not understand. And it's really good.
Very helpful.
Because they can't, once you see the paper, like, okay, what was the
You gotta
problem?
figure out. Oh, no, it saves time on your part. One real quick,
I just have a question on technique. Is there a way to set up a paper and maybe just folding it in half and breaking it down on, showing all the work on one side and then having to clean it up on the other side?
I've seen teachers do that, yeah.
Like that?
Clean it up. But yeah, I was limited on space here, so yeah. Yeah,
So I just
more
wondered if there
organization.
is.
Yeah, you're right. Yeah, Toby did it like that.
I have it all over the page here and then start the other one.
Yeah, he cleaned it up on the other page. Sandra?
Actually, two things. I can hardly see that from the back of the room, with the back of the room person, and asking for it louder. That's really important whenever you're having students explain it and they're kind of a quiet, shy person like one of my best students sitting up there. I'll tell you her story later. So that's important. The reason why I wanted the last word was to explain our thinking in lesson planning. So after class yesterday, or sometime, I forgot when it was, we were planning today, so we were talking about different aspects of it. And we needed time in the class, but we wanted this experience. So we said, could this be an example of a flip? So that's how we got to this being your homework assignment, because it's actually was supposed to be the first thing that you did today. I think, I'm not sure if the team did it, but Browning and I, we go home and we work. So we worked a couple hours last night after we got home. And one of the things that we did is we looked up the research on flipped classrooms, and we said that's supposed to have been sent out to you. Did it? Did you get it yet? Okay, I asked them to put it in Dropbox, so I won't discuss this now. I want y'all to read it. And so that was kind of our thinking in terms of lesson planning. But I've forgotten who said it, the importance of that amount of time that it takes to plan a good lesson. And I want to go back to what Brenda said about getting ahead of herself. As I said, with my students, they have to put every part of the lesson on a PowerPoint so they don't get ahead of themselves. And if you're teaching secondary where you've got multiple classrooms, you get to the last period of the day and you can't remember what was done first period versus sixth period. And so that's a way to have that equity, if you would, in your instruction, so that every period at least gets that core, that scaffold, so you're not getting ahead of yourself, and you've thought things like this carefully through, and you're seeing the problems where kids are gonna have them. You're trying to foresee. You know, things are always gonna come up in the classroom and it's gonna deviate from what you plan. But it's that amount of time to deeply plan, like Tim was talking about yesterday, that you get effective instruction.
So, can I just add something to that? I'm sorry.
Your last one.
Stand up, talk loudly.
So it's hard to plan this way. It's really hard to do that because when the school year starts, we all know we don't have hours and hours and hours to plan. So collaborate with each other, get with each other, talk it through, because you may not write out your plan like Dr. West would want us to. But if you are working together as a team, you know, somebody does the research, the NSES, the NCTM standards, somebody does that part and comes in and says, this is what this says. You know, this should be our driving focus. You know, you have to work together. It has to be a collegial atmosphere. You
And it
can't
gets
do it by
easier with
yourself.
practice. It does. You'll find that you're doing it a lot.
Yeah,
Because
and-
you'll know what the standards say, and you know what the TEKS say. You don't have to go back and learn it again.
But
You know
then,
it.
you know, and I'll never go back, never be afraid to go back and edit it. You can always make it better. You can always make it better.
Laura?
Let's take a 5-minute break. So let's take a 4-minute break. At 9:15, we're gonna start back up here.
Brenda.